So we finished up until here. Okay. And what is the zeroth law of thermodynamics? The zeroth law of thermodynamics states that when the two bodies are at different temperatures, when they are joined together, the temperature becomes uniform, like the same temperature for each body. This is zeroth law of thermodynamics. So now we will study more about the temperature scales, what are in the market, and how do we um, work with different temperature scales. So it is important for us to understand these temperature scales. So as you can see that if we extend these lines, then they meet every line, like for like if there is nitrogen, argon, and water vapor, every other gas, they join at a certain extended point on x-axis, which is negative 273. So temperature in Celsius, if it is negative 273.15 Celsius, that is also equal to 0 degree Kelvin in absolute scale. So in absolute scale, this is known as the 0 Kelvin. So this is absolute zero. So now there are different scales like Celsius in SI system, we have Celsius in English system, we have Fahrenheit, thermodynamic scales like absolute scales. We call this as a Kelvin scale, Rankine scale in English system, SI system, we have Kelvin scale. And how do we find out how do we go from one scale to another scale? So let me show you. The next slide I'm going to show you, these are the formula which you can note down or you can memorize. So usually you have the boiling point of water, which is 100 degrees Celsius. Okay, now the temperature scale here, that Kelvin, if you want to go from Celsius to Kelvin, you have to add 273 into that. And if you're gonna go from Fahrenheit to Rankine, we have to add about 459.67. And if we want to convert from Rankine to Kelvin, then we have to multiply by 1.8 Kelvin. And if you want to go from Celsius to Fahrenheit, we have to add 1.8 plus 32. I think somebody wants to join. Sure. Pending requests. Oh no, this is different. I'm sorry, this There is little bit error in the team. I sent a wrong team. That's why students are unable to join the class. Okay, calendar is this thermal lecture. Okay, so let me resend this to edit. Okay, now I gave another email and updated the link for all the students who are. Okay. Now we have to go over here and let me the pressure, which is defined as the force per unit area. So, and the different units of pressure are mentioned here. Is 1 bar equals 10 to the 5 pascals, or zero point 0.1 megapascal, or 100 kilopascals. 1 atmosphere, it is usually we are concerned with 101.325. So this is important. One, like P atmospheric pressure is 101.325 kilopascals. This is an important information, or we call usually it's about 100 kilopascal if you try to have an estimated value. And then we have some positive pressures, some negative pressure. Negative pressure are vacuum, positive pressure are gauge pressure. So if we want to see the gauge pressure, this is above the atmospheric pressure. And if you want to calculate the maximum pressure, the absolute pressure, you have to add in the gauge pressure, you have to add P atmospheric. So if we have like the P absolute, which is P gauge plus P atmospheric pressure, or P gauge can also be written as P absolute minus P atmosphere. When we have a negative pressure, like if the pressure is less than 14 psi, so then it is a negative pressure, which is also known as a vacuum pressure. And then we have to use this formula. Atmospheric pressure is greater than the absolute pressure in that case for the negative pressure. Okay, so let's do one little problem here. So before I go to the problem, let's do one more slide. Yes. Hmm. Pressure varies with the depth. Like at the surface, pressure is atmospheric pressure, but at the bottom, the pressure increases. So you have to consider this as a height of the fluid. And if I consider the pressure at the bottom, like over, if I consider point one as pressure, atmospheric pressure, plus the pressure inside. So how would you get the gauge pressure here, which is rho gh? This one is the formula. The formula for finding the pressure of a certain head is rho gh. So this is again the same kind of concept, that if you, this is our atmospheric pressure on the surface of water or maybe some other liquid, but if you want to find out the pressure at location 2, you have to add the pressure head of, due to the h, height, depth, and atmospheric pressure should be added at that location. So in this diagram, we are telling, look, the pressure at a certain depth will be the same pressure, like PA would be equal to PB, would be equal to PC, PD, PE, FG. This is all what it is written here, which is equal to P atmospheric pressure plus rho GH. This is what it is written. And the PI and pH, it is for different fluid, therefore it is not the same. The fluid should be the same as well. So if this is the same fluid, suppose this is not mercury but water, then this pressure at location H would have been equal to pressure at location 4 water. But since we have different densities of fluids, then it is not the case. I'm going to explain you, if you have different densities, then how would you find out the pressure difference? I'll explain in a bit. The Pascal's law states that the pressure applied to a confined fluid increases the pressure throughout by the same amount. So pressure P1 at location over here, it is equal to P2 over here. Agreed. Now, this is very useful, that you have to apply less amount of force here to lift large amount of force because of the Pascal's law, equal pressure at all and the location for the same fluid. That will help us to lift the heavy weight with a small amount of force. And what is manometer? So it is used to measure the pressure difference, and it contains either one or more types of fluids such as mercury, water, alcohol, oil, etc. And in this case, if you want to find out the pressure at location 1, you keep on adding the head, rho GH1 plus rho GH2 plus rho GH3. This rho varies from liquid to liquid, fluid 1, fluid 2, fluid 3, and G, everybody knows G is 9.8 in meter per second square in SI system, and G in English system Can anyone write down what is the value of G in English system if you remember? That's good. 32.2. Rena and Caesar are correct. And in this case, if you want to find the pressure difference from location 1 and location 2, when you go down up until here, the rule is you start from one location and keep adding when the pressure head is downward. For example, for the same fluid, P1 is a pressure inside the tube or the device, and then this rho 1 is being pushed downward with a high depth of A plus H. You have to add when you have to be consistent, starting from location 1 equals to location 2, and keep on adding or subtracting. If you go for the second fluid, you have to draw a line, and the pressure head, if it is upward, you have to subtract that pressure head. This negative sign, try to understand. I will explain it again, but let me explain to you here. When you are having different fluids and you want to find out the pressure difference in a manometer, then you keep on adding the pressure heads which are downward direction, and pressure head which are upward, keep on subtracting those pressure heads. So for this row 2, pressure head is H, which is upward, therefore we have a negative sign. And again, if we are moving upward to reach the fluid at location 2, then we have to subtract this pressure head A, and then equals to P2. And P1 minus P2 can be rearranged like this: P1 minus P2 equals to rho 2 GH GA. So we are left with, it's the same formula written over here. Okay, guys, this is another example. Here, this is another example if you want to find out the pressure at location 2. So in this case, this is atmospheric pressure. So P2, let's do the draw a line here. P2, if you go from here downward, negative. If you see, as you go downward, you add the pressure, but if you go upward, this is the head. You subtract rho. I mean, say this, whatever fluid is, we don't know. This black color fluid is rho GH. Negative sign is more important than the substances. So that is equal to atmospheric pressure. This is the same formula. Or you can rearrange it. P2 equals to P atmospheric plus rho GH. The barometer is used to find out the pressure, atmospheric pressure, and the height of the column inside this tube determines the atmospheric pressure at a certain location, and that is equal to rho GH. So if you have different fluids, the height will vary. For mercury, the height of the column is 760. Atmospheric pressure is 760 of mercury at 0 Celsius. It is independent of the size of the or the diameter of the tube, but it depends upon the fluid, which is for water, it is different. Okay, let's do one problem here. Now, in this case, it is given, this is our book. Sorry, this is our question at the end of the chapter. Let us solve this problem. This the water in the tank is pressurized air. In the tank is pressurized by air. So this is water. It is being pushed downward by the air pressure. So pressure over here, it is P1. And determine the gauge pressure. So you have to find out the gauge pressure. This is atmospheric pressure. So if I talk about the gauge pressure, which is the pressure difference, you have to subtract the atmospheric pressure from the pressure inside the um, tank. So now let's talk about going downward. If as I mentioned, the rule is you start from one location and equate to the other pressure at the other location, which is P atmosphere. So how would you start? So P1. So if you go down, so this is the pressure difference. If you cancel this out, the pressure difference is this much. You will tell me, should I have a positive sign for H1 going downward or a negative sign? That's important. Can you tell me in the chat box, should I write down plus rho GH or minus rho GH? Positive, that's correct. Going down is positive, rho GH1. And make sure the rho is for water. Now let's talk about oil. If you just subtract the even difference, but the uneven difference is H2. Now again, you are adding this pressure because you are going downward. This pressure head is oil GH2. Now you will tell me, if I draw a line to subtract the even portion and then H3, you will tell me, should I write down rho GH3 as positive or negative? This is important. If you understood this concept, it will help you solve the problems. For the third case, H3, it is mercury. Is the pressure head, you will add that pressure head or subtract, negative sign or positive sign? Negative. Taylor is correct. Why negative? Because this is the pressure head when you are going upward. The other pressure heads when you are going downward. Look, it's quite messy here. I want to just erase it to tell you again. This is important to understand. Why did I add? For water, you have to draw a line and see what is the pressure difference. This is the pressure difference, and you have to add it going downward. For oil, you have to draw a line to subtract the even portion, but then you have to see the extra head which is going downward to reach the next fluid. So therefore you added rho GH2, and you have to draw a line for the mercury to find out the extra head, which is H3, and this is reaching the level 2, and negative sign rho GH2 for mercury equals to P2. This is how you do the math for the everything. This is also equal, P2 is also equal to P atmospheric pressure. I would say P atmospheric. And then the gauge pressure is P1 minus P atmospheric pressure, and that will help you to find out the answer. I'm sorry, this is H3. Okay, now let us write down the values here. H3 is 0.46. Negative sign. Density of water is 1000 kilogram per meter cube. Rho G H1. H1 is given as zero point 0.2. For oil, the density of oil is 850. And H2 is given as zero point 0.3. And if we do the math here, so let me do the math for you guys here. You can verify. You can open your calculators and verify the answer. So I'm getting 56,000. And if you're getting 56,000, that's correct, which is very close. So in this case, this is in pascals. The unit is Pascal. Pascal, 1 Pascal equals to 1 Newton per meter square. And if I want to find out the answer in kilopascals, I will divide this by 1000 to find out the gauge pressure to be equal to 50, let's say 9 kilopascals. Now, before I go to the next question. Please type in either yes or ask me some questions if you have still not understood this problem. If you have understood, please type in yes and I will move forward. All the lectures I will upload on the YouTube recordings, as well as I will upload the PDF format. Do you like the idea of uploading the lectures on the YouTube, or should I just leave it in MS Teams for you? Okay, Brina says YouTube. Okay, I will download it from MS Teams to upload it on the YouTube. All right, guys, let's go to the next question. Let us do this problem. This is fresh water. Like this is a pipe, a horizontal pipe. You have attached a manometer. It's like a long pipe. Okay, you have attached the manometer to find out the difference between the pressure of fresh water and seawater flowing in parallel horizontal pipeline. These are the horizontal pipes. Okay, and they are connected by the YouTube manometers to find out the pressure difference. Determine the pressure difference between the two pipelines. Take the density of seawater at the location. Seawater, the density of seawater is 1035 kilogram per meter cubed. Can the air column be ignored? Can we ignore this air column? So we will see. Remember the remember the pressure head. Pressure head is rho gh. And for air, if we want to find out, rho of air is 1 kilogram, 9.8. H is 70 in this case, 0.07. Right now I'm just telling you, can we ignore it or can we not ignore it? I'm gonna show you in a moment. Okay, so before I go to the further, I want to just calculate it for you. 9.8 times 0.07. This is in Pascal. The pressure of this column, pressure head, this column is 0.686 pascals. So let's start from here. I'm going to start from pressure in location 1. And I will go up until pressure in location 2. Okay, now let's start from 1. Going down is adding the pressure, meeting the next fluid, mercury. And this is fresh water. Fresh water in the horizontal, as well as fresh water is pushing the mercury downward. So you have to add it. Raw fresh water is pushing this downward. 0.06. Why am I writing 0.06? Because 60 divided by 1000 is zero point 0.6. I'm sorry, this is 0.6. It should have been 0.7. Why am I doing this? I'm sorry, this is 0.0. I was correct. 60 divided by 1000 is 0.06, correct? And now we have to find out the next fluid. going upward. It is going upward, so you have to subtract for mercury. Why am I there is a mistake, guys. I was confused. This is 1 meter equals to 100 centimeters. So this should have been divided by 100, not uh by thousand. Sorry about that, but it's okay. You, no, you can also stop me and explain me if I'm doing some mistake in the conversions. So right now, I think this looks good to me. And then going for upward for air column. Look, this air column is upward, so I have to subtract the air column. And then the next fluid is going downward for seawater plus seawater GH2 0.4. Now we have done the equation. The next thing is just to subtract or add or multiply. You have to find out, determine the pressure difference between the two pipelines. If you do the math, you should get 3.4 kilopascals. I'm not doing the whole calculation to save the time, but before I move forward, do you understand up until here? And for pressure air, the one which I talk about, it is 0.686 Pascal. But in kilopascals, that is also equal to how much? 0.0069 kilopascal. So yes, for air, that column can be ignored as compared to the large value of 3.4 kilopascals. Do you guys understand this question? Please type in yes if you understood this question. So the question was asked over here, how do you solve this without having the density of mercury? No, we have to know. We have to know the density. It should have been given 13,600. And there is another important technical term, specific gravity. We call it as a specific gravity, and it is defined as the density of a substance divided by the density of water. And density of water in SI system is 1000. And for mercury, the specific gravity is 13.6. This is dimensionless. Let us solve one problem. Okay, so the question is, a multi-fluid container is considered connected to a U tube. It's a manometer, and for the given specific gravities have been given. Like oil is zero point 0.9, means oil is lighter than water, zero point 0.9, water, and then glycerin, which is heavier than water. So find out the gauge pressure. I would say P gauge, this is P atmospheric pressure, and this is PA. So P gauge would be equal to PA minus P atmospheric pressure. So let us start from here, and then going downward, keep on adding, either add or subtract. I'll let you know in a bit. So let's do this. So P atmosphere for oil, the pressure head is 70 centimeters. Should I add or subtract that pressure head? Can you tell your professor? That's good. You have to add it because it is going downward. To be consistent, you have to add the pressure head. So I'm gonna use the raw oil G times H, which is zero point 0.7. And then water, for this pressure head, you have to reach up until here. Do you have to add rho GH or subtract? What do you suggest me? Add, that's correct. So you have to add for water zero point 0.3. So now the glycerine. So in order to do the glycerine, this is all glycerine, okay? The color is probably confusing, but if I draw a straight line, this is the difference in the two sides. So what do you suggest? How much is the difference? 90 minus 20, 70. So do I have to add the 70 or subtract? Good. Subtract, because this is going upward to reach this value up until here. Subtract is the correct answer. For glycerine, rho GH zero point 0.7. Make sure you find the difference of the two sides. The difference in the two sides is 70 centimeters for glycerine pressure head, and that is equal to PA. And we have to find out PA minus P atmospheric pressure in order to find out the gauge. PA minus P atmospheric pressure, then you rearrange everything, you get 0.471 kilopascals. Now here the specific gravity, as I mentioned, this is the formula. For specific gravity, you can find out the density. And now for glycerine, so P for glycerine at A, it is also asked, determine the height of mercury column that would create the same pressure at A. The glycerine, this is also, I believe this is pressure A for the glycerine. So how would you find out that rho GH for mercury? The pressure difference 4.471 kilopascal equals to, so this is height at, if you do not use the glycerine but you use mercury, so what should be the pressure head difference for mercury? It would be 0.353. Therefore, it is preferable to use mercury because of the smaller tubes. Okay, now guys, we have done this question. Please type in yes if you understood this problem. I will suggest you when you go home to try to follow this lecture and do these problems. You will have your first quiz next week on Wednesday. And this will cover both homeworks which I have uploaded on the D2L. And this is open book but closed solution. You will be having opportunity to do it by open book. All right, so let's go to the okay, let's go to the next question. Now, in this case, the question states that the force generated by spring is given by F equals to kx. Okay, so let's this. The spring, this is exerting, I'm sure this is exerting force. Let me redraw the arrow here. This is exerting force on the piston, and the fluid inside the container under the piston head is pushing the piston upward, and the fluid around the piston in this area, this is pressure P3, and there is also pressure here. So if I draw the all the forces in the y direction, I would say equilibrium condition, all the forces they are equal to in the y direction, assuming my positive is downward. So how many forces are above this piston? There are three forces. One is due to the spring. I would say sub K, because K is usually the stiffness. Force due to the spring is K times X. And another force is due to the pressure in this pocket. Look, I would say P rather than P, I would say F. Since we are balancing the forces, so I will use forces. And the pressure P3 is also exerting force, and this is due to the fluid in this area. And the upward pressure is causing the force on from the bottom upward. So let me say positive is downward, so I can write down Fk plus F2 plus F3 equals to F1. And then the question states the spring constant is given, okay. Pressure P1, pressure P2, and pressure P3, they are given. If the piston diameters are given, how far will the spring be deflected? You have to find out this x. So in order to find out the x, first of all find out Fk. So can you rearrange everything? F1 minus F2 minus F3 and F1. You remember pressure equals to force per unit area. So if I write down F1, can I write down P1 A1? Can I write down P2 A2? Can I write down P3 A3? Now, what is area 1? Area 1 is, if you look from the bottom, is like a round shape. Area 1. So can I write down like area 1 equals to pi by 4 d1 square. And if you do the math, the diameter has been given 8 centimeters. And pressure P1 is given area 2. The diameter of this pocket, if you look from the top, it's a round shape, pi by 4 d2 square. And as far as area 3 is concerned, then you have to do the math a little bit, because you have to see, look, area 3 is the total area, this area minus this area. If you take a closer look, you have to subtract P, like area 2 from area 1. Do you agree with your professor? Area 3 would be pi by 4 d1 square minus d2 square. If you agree with me, please type in yes, and then I will explain further. That's good. Okay, so now let's find out the final answer. So if you plug in everything here in this equation number 1, and Fk would be equals to 11 kilonewtons, and that is equal to K times X. And if you solve for this, you get X equals to 1.72 centimeters. And this will be your job to verify this answer. I'm trying to skip some of the calculations to save some time. But if you still want me to do that, I can do that for you. Please verify this answer at home, and we will, but the methodology, if you have understood the methodology, please type in yes in the chat box, and then we will move to the next question. Molly says yes, Alison yes, Darius yes, Sanjana yes. That's good. Okay, Sarah yes, that's good. Okay, let's go to the next question. Let's go one more problem. A vertical frictionless piston cylinder device. So a vertical piston cylinder. This is a cylinder. This is a piston. I should have reduced the size of the piston here. Okay. I would use this bigger size here. It's similar to the previous problem. Piston can contain the gas. The gas is contained here at pressure is 180 kilopascals. Absolute pressure. The atmospheric pressure outside is piston area is 25 centimeter square. Determine the mass of the piston. So we know that force, or if you remember, W is also the force. W equals to mass times gravity. And so if we know that the force over here is at location A equals to, so W, so I'm going to balance this out. So let's do this. So if I draw the free body diagram of the piston has its own weight, and there is a pressure exerted by the atmospheric pressure and the force generated by the gas inside. So this is F1, this is FA, this is W. So I'm going to draw the equation for the force balance, like FA plus W equals to F1. W equals to mg. So you can find out individual value here, and only the missing thing is m, which is 20.4 kilograms. So if you want me to solve one question for you, I can do the calculation just for instance. For let's do one calculation for this one to be make to make it easy for the students. So I'm gonna copy this and do this for you. Atmospheric pressure is 100 kilopascal. 100 kilopascal. Let's find out in just 100 to be final answer will be kilonewtons. Area is 25, but it is in centimeter square. And you know that 100 centimeter or 100 square centimeter square equals to 1 meter square. So now this is Newton per meter square. So the answer is in kilonewtons. So if we do the math here, I'm sorry, this is 0.25, correct? And F1, gas pressure times area. The gas pressure inside is 180 kilopascals. So 180 kilopascal times area 1, which is 25. So if you do the math here, so I would say 180 times 25 divided by 0.45 kilonewtons. So this is 0.45. This is how much? 0.25. So if I write down the same equation, 0.25 kilonewtons plus W 0.45. W would be equal to 0.2 kilonewtons. So if we divide it by 9.8, I get about 20.4, which is the same what I just wrote earlier. It's 20. Do you understand this calculation? If you understood this, please type in yes. And if not, I'm here to help you to answer the question. But when you are at home, do it again to understand it clearly. Let's solve one more problem. Now you should be able to solve the whole homework problems at home because they are related to similar questions. So one more problem I can solve for you. A manometer containing oil, density is given, is attached to a tank filled with air. And suppose this is a tank. Air is it's a rough sketch, just it is atmospheric pressure, and then if the oil level difference between the two columns is 36, and the atmospheric pressure is 98 kilopascal, determine the absolute pressure in the of the air in the tank. So you have to find out absolute pressure. Now if you start from here, location 1, and go over here, then I would say P1. Now you will help your professor. Should I add or subtract rho GH? 36. The head is 36. Should I add or subtract the head to reach this point? Atmosphere. Rho GH, which is 36. Yes, you have to subtract it. That's correct. Because look, this is the pressure difference. Even you have to subtract the, you are going upward. You have to subtract it. That is equal to P atmospheric pressure. And P atmospheric is 98 kilopascals. and this can be divided by 1000 to convert it into kilopascals. So P1 can be found, which is the absolute pressure. I think this is 101. So this is your answer. Do you guys understand how to solve the pressure difference in the manometer? How to find out? These are the two important problems. You will see similar problems in the quiz or test. You have to understand the concept. If I give you the piston and the forces due to the gas inside the container and the forces outside, you should know the force balance in the y direction. And this is students have been doing the force balance equation for a long time in statics uh, subject. So you should know. And today you learned about the manometer for different densities. Manometer, this is also manometer, barometer. We did not solve any question about the barometer, but it is very trivial that you just know the height of the mercury column, which tells you the pressure of atmospheric pressure, which is open. So we have done quite a lot of problems today, but the concept is more important. If you have understood these problems, please type in yes. If not, I will explain them again. I want to see some students either saying yes or they want me to explain further. Okay, let us do the next topic. Let's change the topic here. This is the last two slides. Summary, what you've learned today. The next topic is chapter 2 slides. And now we have started chapter 2. Energy. How do we transfer energy from one form to another form? Energy, pressure energy, kinetic energy, potential energy. I'm giving you some big picture. Do you want me to give you a mini break or you want to have early release? Okay, I will give early release, but let's understand the big picture. Energy. Okay, if you have a mountain and a rock is stationed here at a height h1. What is the potential energy of this rock? You know the formula mgh 1. And once the rock falls down, just before it lands on the floor or on the ground, the kinetic energy is maximum due to the maximum velocity before it touches the ground. Half mv square. This is important to understand that at any instant, the law of conservation of energy states that the summation is same. The sum of two energies is same. This is what we learned in the previous lecture. If I go back to the previous lecture, Maybe I'm unable to find it, but there is another type of energy, pressure energy. And if I write down pressure per unit density, this is energy due to the pressure. And energy due to the kinetic energy, specific value, you just write down half V square. I would say joules per kilogram. Joules per kilogram. Energy due to the potential energy. Sorry, not half. Rather than mgh, you will write down gh. So if you add all those types of mechanical, and we call these as mechanical energies, you add them up. Pressure, specific pressure energy plus specific kinetic energy plus gh. This is also known as the Bernoulli's equation. You have to add all these equations. We will talk more about it next week. So that's it for today. Thank you guys.
Thank you, Professor. Have a good evening.